draw the most stable chair conformation of cis-1,3 diisopropyl cyclohexane. So we begin by drawing cyclohexane, and we're going to number it any way we want. I'm going to number it this way. And then I'm going to add my groups. So I have an isopropyl group on carbon 1 and carbon 3. This is what an isopropyl group looks like. 1 and 3. Next, here it says cis. What does it mean when it says cis? So the way we will draw a cis compound, that means both groups are in the same plane. So either you will draw both of them on a wedge, or you will draw both of them on a dash. For example, let's say that I will draw both of them on a wedge. You could do either way, it does not matter. This is my cis-1,3 diisopropyl cyclohexane. Next, what I'm going to do is I'm going to draw my chair. So the way we draw a chair, and let's just change our colors. We will draw two chairs. Chair number 1, and you can watch my previous video about drawing chairs, and it's flipped chair, flipped conformation. Okay, now that I have drawn two chairs, the next thing I do is I'm going to number my chairs, and the way I number is I go from the top right corner 1, 2, 3, 4, 5, and 6, and then I'm going to put my carbon number 1 here. When the chair flips, carbon number 1 is no longer there. It changes one carbon over. 1, 2, 3, 4, 5, and 6. If I have a wedge, that means I need to put my groups up. So, and if you have a dash, it's going to be down. Both are wedges, so I will put isopropyl on group 1 up and isopropyl on group 3 up. And to help you remember the up and down positions, I have drawn these chairs, and I have labeled each group as up and down just to make it easier for you. So on carbon number 1, my group is up. This is my carbon number 1 here. Up is straight up. So I'm going to put my isopropyl group straight up. On carbon number 3, I also have up. 1, 2, 3. Carbon number 3 up is straight up as well. Now let's go to the flip chair. Carbon number 1 up is diagonal parallel to this line. So I'm going to draw up, isopropyl up. Next, carbon number 3, where is up? Up is here, parallel to this line. These are my two chair conformations of cis-1,3 diisopropyl cyclohexane. How do I choose the most stable one? I'm going to label my groups as either axial or equatorial. If my group is straight up or straight down, that is axial. As you can see, in my first chair, both groups are straight up. That means we have axial. I'm just going to label it as A. If my groups are on a diagonal, not straight up or straight down, but at an angle, these are called equatorial. Equatorial. So these groups here, this is equatorial and this is equatorial. The chair conformation that has the most groups in equatorial positions is the most stable. Axial positions are not stable because they're sterically hindered from the 1,3 diaxial interaction with hydrogens. So when choosing the most stable chair, I'm going to choose the chair that has the most groups in equatorial positions. Here I have both groups in axial. Here I have both groups in equatorial. Which chair is most stable? This chair. This is Mayya. Please comment if you have any questions or if there is a topic that you want me to make a video about.